Yeah, so this is our project that we created. It was about predicting the stroke risk in seniors. Like I mentioned before, they are very prone to these type of diseases considering their age. And also what was interesting when we learned about is that 75% of strokes actually occur in seniors. And because of that, we knew that it was such a real world issue among the elderly. And, considering the impact that, the elderly has had on my life personally with my grandmother, who's taken care of me a lot throughout my whole life, I knew that, I wanted to create a project that could kind of help them and, kind of care for them because they once cared for us before. So going to this project, we have different factors that any user can input to predict the likelihood of them experiencing a stroke. So these different factors like age, heart disease, smoking. And what we did notice is that the BMI had a major impact on the likelihood of someone experiencing a stroke. I'll just show you a demo. If we have like, say you have hypertension or you have experienced heart disease before, let's make your average glucose level like 192, for example. Um, Prediction: there's no stroke. I
Hmm.
see the probability is pretty low, but this should change if we change this and we make the BMI 30, for example. Let's see what happens now. Then it changes obviously because smoking obviously leads to long-term health negatively, like a negative impact on your health. And like I mentioned before, it's just changing the BMI also had a huge difference as well. And yeah, so we're confident that you know people all over the world, particularly the elderly, can use this project and determine whether they are likely of experiencing a stroke. And then if they are, they can take further steps, whether that means, going to a doctor, taking more medicine or whatever.
Okay, it looks great. I think your project works perfectly fine. But I have a question that who was your teammate, Shaurya?
Ariman. Ariman,
Okay. So what was your experience with him?
experiencing was great. I think the best part was our just communication. Just knowing like what times we could meet, what times we can't meet. And I think that whole process was just very smooth. A lot of communication between us about our availability, and there's no last minute dropouts. There's always clear communication with us, so the process with him was very smooth. And when we would go on our meetings, both of us just did equal work, and not one person would do more, and it was definitely an equal effort between both of us to create this model, which turned out pretty good.
So that's great.
Yeah.
What was your role in this project?
My role, so first, a lot of the times our instructor or our mentor would make us just share a screen so we could, show what we did. So a lot of the times I would show him, our Excel, so our data sheet, and I would be responsible for cleaning the data to make sure that there were no outliers that could potentially affect our model or, make our model overfit on a particular piece of data. Um, and then just being able to not only clean the data but also write the code, whether that be like from ChatGPT, which is what he advises to do, but obviously not just copying the code from ChatGPT, also ensuring that learning it was really important for us as well.
Okay.
um, and yeah, the code and the
So,
so was really important, and obviously finding the data set on Kaggle as well. I was also
mhm,
to find it as well.
okay, that's great. So I have a quick question. How accurate do you think your project is?
um I would say it's not entirely biased, but I wouldn't say it's completely accurate as well. What I did notice is that our data set was trained on about 5,000 data set values compared to what our mentor originally wanted before, which is around 20,000 values. I think that given that our data or our model was trained only on around 5,000 values. I think that it could be a lot more accurate if we gave it more data sets. So as a result, more values to work with. I think you can see here that I think the BMI really has, I think, too big of an impact on the likelihood of a stroke. And as a result, it seems way too heavily biased towards the BMI data set. I think that if we were to get more data sets from Kaggle, then our model would be the data would be a lot more balanced and it would be a lot more accurate as well. But nonetheless, I'm still pretty happy with it. But definitely, if we could train it on more data, I think it would be more accurate.
Okay. So, do you have any future plans? Like you said, you want to add more data to it,
Yeah.
then it could be accurate. So, do
Mhm.
you have any future plans with this project?
Yeah, I think definitely the goal of this model was to make it more large scale throughout Americans and globally, particularly. I think the best way of achieving that was to probably create into some type of app where a lot of people could use it. And I think that if we were able to, create into an app where multiple people could use it, people could really understand the impact of our model and how it could prevent people from experiencing a stroke, which could be really fatal. So yeah, definitely one of the goals is to make it more of a large scale and make it more accessible to people all over the world. And whether that be creating it into an app so people could use it, or even allowing doctors to be able to use the app to treat their patients, whether they want to use the app to understand um, whether their patient is likely of experiencing a stroke based on these different factors, based on what their average glucose level is, whether they've experienced a heart disease before, their gender, or etc.
Well, that's great. I think we can move to the presentation now.
Okay. All right. Wait, let me. Okay. So yeah, like I mentioned before, our project was focused on preventing strokes in the elderly. So our problem statement. So one of the reasons we wanted to create this type of model was because seniors are at a really high risk of strokes, whether they're unaware or not. And this is evidenced by the fact that 75% of strokes are experienced by the elderly. And given that this number is so high, and given that strokes and this medical condition is very common amongst this group, we knew that we had to create a model that could sort of prevent this from happening, and I guess make them more aware of the likelihood that they are to experience a stroke.
Okay.
So why we chose this problem? So first, in the impact. So we knew that the elderly has obviously had a major impact on all of our lives. Personally, like I mentioned before, my grandmother had a huge impact on me personally. Just growing up, teaching me how to walk, um, just a lot of different things. And I knew that because, all of these elderly people caring for us, we knew that we kind of had to give it back and care for them, which is why I wanted to create a model that could positively impact them. And our interest in it, we were very interested in healthcare, as I mentioned before, because we wanted to give back to the elderly for what they've done and their impact on our lives. And also because we knew that can prove life threatening. We knew we wanted to, um, create a model that could prevent seniors from experiencing such a fatal disease. And finally, importance because strokes is one of the leading causes of death and disability globally. We knew that it's a very fatal condition that can kill a lot of people in both elderly people and people of all ages alike, but elderly particularly. So our workflow and our process of doing this project are our objectives and goals first. We'll go into that. Um, Obviously, we wanted to make our model more large scale. so that everyone could use it, not just family members, but everyone across America, because that would show our real world impact on the world and that everyone was able to use it, not in America particularly, because obviously we live here. Um, Second, we wanted to our model to be accurate of at least 90%, because obviously if our model isn't accurate, then it won't be useful to people because it won't be reliable. Um, Finally, implementation and learning. We not only wanted to learn how to train this model so we could, apply it to other projects, but we also wanted to implement it in different fields, like the medical field, for example. We wanted like actual doctors to be able to use the model for patients at risk of a stroke, so that they could determine whether their patient is likely to, experience a stroke. And depending on the answer to that, they could provide further treatment to make sure they can experience it or at least prevent it from happening. And next, our process of doing this, creating this model. First, we wanted to find a data set in Kaggle related to our problem statement. So Kaggle obviously is home to a lot of data sets related to AI and ML in different fields. And given that we decided on our topic of people senior healthcare, we narrowed our search to finding data sets related to that topic. We finally were able to find a data set on stroke prevention in the elderly. Um, and given that we had a data set, we knew that we had to first, split the data into training, testing, and validation. So obviously training so that the model could learn about the data from the data set, and from there understand patterns and relationships. And then the testing, so obviously around like 10 to 20% of the data would be for testing, so that the model could, or so we could test the model to see how accurate it was, and depending on that, we could make changes. And finally, we had to split the data into about 10 to 20% of the data into validation, to make any changes to our hyperparameters as well. But ultimately, like one of the sorry, my mom's calling. Sorry about that.
That's fine.
One of the reasons, one of the problems that we experienced was with our data, because what we noticed is that when we like put all of our data into like a Microsoft Excel sheet, there were a lot of outlier values that we knew like couldn't be possible, or a very low chance of that happening. For example, we had um like data of someone having an average glucose level of like over 200, and we knew that not one, that was a very low chance of happening, and that because it was such a low chance of happening, it could affect our model into thinking that is actually a highly possible value amongst people, which obviously it isn't. So once we were able to clean our data to ensure there are no outliers and to ensure there are no odd values, we were able to do that by applying filters in Microsoft Excel. Delete like values greater than 200 in our average glucose like column. And as we were able to do that, um, we finally went on to our model training. Now that we had a clean enough data set, we were able to train the AI model based on the data composed of 5,000 values as well. But to be honest, there was actually more than 5,000 values in the original data set. But because we were cleaning and removing some of the data, it ultimately reduced to around 5,000. So next, more about our model. So like I mentioned before, it was trained from a Kaggle data set focused on predicting strokes in the elderly. Then our two type of models that we used was first extreme gradient boosting. One of the main reasons we wanted to use this was because its use of decision trees within the model. We know that decision trees can be used to predict the outcome of a situation based on different factors, and that directly applied to our topic where we had different factors like hypertension, age, gender, and based on those factors, would that lead would that lead to a higher chance of someone experiencing a stroke or not? And then obviously after linear regression, we wanted to determine, any relationship between independent numerical variables like the age, um, and then determine a relationship between that and our target feature, which was the likelihood of someone experiencing a stroke. Then ultimately, after we were done, sorry, hold on. After we were able to um, do that and create our model, we wanted to deploy it on a streamlined user interface so that we could create a UI where people could um, apply the different factors and input their data based on whether they had heart disease, whether they were married before, input that, and then from there um, it could predict stroke probability based on the inputs. And by the way, all these inputs and factors are from the data set that we used from Kaggle. And like I mentioned before, the BMI, along with the smoking and the age, changed the result. And heart disease and hypertension, glucose level, somewhat, but not as significant as the BMI, age, and the smoking. And the factors with the least amount of effect on the likelihood was, marriage, gender, work type, and residence type. So in the future, like I mentioned before, we want to make our AI and develop it into an app, so that it could be accessible to everyone in the world, and that yeah, like I mentioned before, the app so that it could be accessible to a lot of people. And we wanted to train our AI model because personally, after understanding how certain values could alter the data, um, we knew that we wanted to train our model on more data so that the data set could be more balanced and the model could be more accurate. We also wanted to add more features. Maybe there were some factors that might influence whether a person experiences a stroke that maybe we didn't include, and we could look into more into different data sets, or just from pure research as well.
Okay.
Ultimately, we wanted to use these factors to create a final product. And ultimately, what we learned is first, how does an AI work? Ultimately, we're able to understand how AI is defined by the capability of like the computer to perform human-like tasks based on different data. We also learn how to choose an AI type based on our data. What type of factors did we need? Linear regression to understand the relationship between numerical values and the final output, like our target features, or did we need for example, like an extreme gradient boost, which utilizes decision trees to understand how do different factors like affect the outcome. Finally, able to learn how to split clean and train AI, which as we were able to understand and finally figure out were very huge factors and very important in creating an AI model, because not doing these proper steps could ultimately impact how the performance of the AI model. And finally, we're able to understand how to deploy it onto a streamlined user interface so that many people could use it online. They could just go into the UI and input their data, and then from there, understand their likelihood of experiencing stroke.
Okay.